All right, so we're going to take a look at the nth series test today. So the nth series test basically says as we increase n towards infinity to that nth term, what is the limit? Now, there's a couple things that's going on here. So if the series converges, then what we know is that the limit to the nth term is going to be 0. Now, but here's the thing, is it doesn't work the other way around. If we know that the limit is equal to 0, it doesn't necessarily mean it converges. It still may either converge or diverge. So when we kind of work with the converse of the statement, it says if the limit as n approaches infinity is equal to 0, then the series may converge, or it may diverge. Right, we don't actually know. We'd have to use some other test to figure this out. So really what today we're going to do is we're just going to use this nth term test to see if something diverges. If we're unsure, we may be able to use a different test, but ultimately it'll depend on what tests we have and which ones we may be able to use. So using the nth term test, we're going to look for the limit as n approaches infinity. If it does not equal 0, then it diverges, right? So if this test, if the limit does not equal 0, we know that this series will be divergent. All right, so let's take a look at a couple examples here. So the first one here, we're going to use the nth term test to make a conclusion about divergence for each series. So for our first example here, what we'll do is we'll find the limit of our series. So the limit as n approaches infinity of our series here, so of our 3n cubed plus 1 over 5n cubed minus 2n squared plus 1. Now, with this one, we have equal degree terms. So what we could do is we could find the limit of just those leading coefficients. So we know the limit is equal to 3/5. And so since this is not 0, we know that this series diverges. And we know that by the nth term test. And that's it. That's as simple as that. All right, with number 2 here, we have a different series. Now, if we apply our our limit for this value here, we know that this is 1 over 2 to the n is a smaller number. It's less than 1. It's the limit of this series, and as n approaches infinity of 3 times 1/2 to the nth power. This number is just going to continually get smaller and smaller and smaller, so we know that this limit approaches 0. Now what that means is it may converge or it may diverge. We actually don't have a conclusion. But what we talked about yesterday is a geometric series. And with a geometric series, we could test the r value. So in this case, we know the r value is 1/2. And since the absolute value of 1/2 is less than 1, we know this thing does converge by the geometric test. So the geometric series test. So sometimes if we're not sure if it converges or diverges, we get that 0. We can use other tests if we have them, right? So you guys only really have one test so far. We'll continue to learn more to kind of help that grow through. All right, so for our next one, let's do the same thing. We'll apply our limit test. So the limit as n approaches infinity of 1 over n. Now this limit is 0. So what that means for us is we have no conclusion, no answer based on what we have. Now we will, again, learn more ways to work with these, but right now, no conclusion. We do not know if this thing converges or diverges. Okay, so for number 4 here, we have the limit as n approaches infinity of 2 to the n plus 2 over 2 to the n plus 3, and then we have this plus 1 at the end. Now, this plus 1 is doesn't really change the equation too much, and if we look at this, we can actually rewrite these two. So I'm going to rewrite this limit as n approaches infinity as 2 to the n times 2 to the second over 2 to the n times 2 to the third. And what we can see is that these 2 to the n's are going to cancel. And I have a limit that is not 1. That is not 0. So I have a limit that is 4 over 8, which is 1/2. Now what that means is this thing, it diverges. And again, by the nth by our nth term test. All right, so not bad. One last example for us to take a quick look at. We have the limit as n approaches infinity. So the limit as n approaches infinity of e to the 4n over 3n. Now when you guys do that, we end up with infinity over infinity. Now that's not an indeterminate form, so we cannot determine what the limit of this one is, so we could continue on and attempt to find the limit another way. Now when we have an indeterminate form, one option is that we could use L'Hopital's rule. So we'll take the derivative of the top, which is going to be 4e to the 4n, and then we take the derivative of the bottom, which is just 3. And now when I substitute infinity in, I get an answer of an infinite limit. Now, since that's not 0, we find out that this series diverges, again, by the nth term test. And that's it for this test.